Welcome to Notebook 13, Hello World with LangChain. In this notebook, you're going to learn how to interact with LangChain to generate chat completions using our local Llama 3.1 AP Instruct model. This introductory exercise is going to help you understand the basics of setting up and using LangChain in a Jupyter environment. By the time you complete this notebook, you'll have an introductory understanding of LangChain. You'll be able to generate simple chat completions using LangChain. And through your experience here, you'll be able to compare and contrast the differences between using LangChain versus the OpenAI library, which we used in the previous notebook for chat completion. To begin with, we're going to import the Chat NVIDIA class from LangChain NVIDIA AI endpoints. And this Chat NVIDIA class is what's going to allow us to interact with our local Llama 3.1 AP Instruct NIM. If you use LangChain for other models, this is one of the only places where you will likely need to change your LangChain code to work with a different kind of model, right? In the case of NVIDIA NIM, we need to use LangChain NVIDIA AI endpoints and specifically the Chat NVIDIA class. But for other models like Anthropic or OpenAI or you name it, you'll see there's going to be things like import OpenAI or import Anthropic, probably from slightly different packages than what we're using here. So yeah, long story short, for NVIDIA NIM, we're going to use Chat NVIDIA. All the rest of the code after using Chat NVIDIA to create a model instance is probably going to be the same for other LLMs, other chat LLMs that you're using LangChain for. But this first import, if you're working with different models, is going to be different. Yeah. So to start using LangChain, we set up the Chat NVIDIA model instance. So this involves very similar to the OpenAI API, configuring the base URL and the model name. So here again, we have our base URL. It's the same place that we're serving our model from. And our model name is also the same model from the previous one. But here, instead of using OpenAI, we're using Chat NVIDIA. We again pass in the base URL and we again pass in the model. And here we're passing in a third and optional argument called temperature. And let's take a moment to talk about what that is. You might notice here we're setting it to 0. And temperature itself is intended to be a floating point value between 0 and 1. And what it is, it's a way to control or have some control of the randomness of a model's responses. When it's set to 0, the LLM is always going to generate the text that it considers as having the highest probability of coming next. So when set to higher values, it can or is encouraged to generate text that is not necessarily what it considers to be the very highest probability of coming next. And by doing this, in practical terms, it introduces randomness and a sense of creativity into the model's generations. We're not going to discuss modifying temperature to higher values in great detail here, but the main takeaway here is remember that if we set it to 0, or if anyone sets it to 0, it's because you want deterministic responses, which is to say, given the same prompt, the model will reply in the exact same way. And the higher you set it, the less deterministic the responses are going to be. Now, the main reason we're setting it to 0 here in this course context is just for reproducibility in the model responses, so that as we're instructing it with a video, we can assume that you're going to be getting the same responses that we're getting when we go through the exercises. In the real world, depending on what you're doing, if you're looking for accuracy, correctness, predictability, then you should definitely set this to 0. Sometimes in generative tasks, creative tasks, you actually want to introduce some liberty, right, in how the LLM generates its responses. So you might tweak this value to be a little bit high. Temperature is one of several parameters that we call hyperparameters. And if you're interested in learning more about hyperparameters, including temperature, but also a couple of more, we've included an appendix notebook here called 99 Appendix Hyperparameters. You can either open it or link to it here. We're not going to cover it in detail in this walkthrough. It's not a core part of what we're teaching in this course. But for those of you who are curious to learn a little bit more and get a better intuition about how these hyperparameters work and impact the way that LLMs generate next words, feel free to check out that appendix and go through it, and you'll learn a little bit more there. Okay, so before continuing, let's just recall we've used Chat NVIDIA now to get an instance. An LLM instance is what we're calling it, and we've defined it as a variable called LLM. So now that we have that, we can start to send prompts to our model and get chat completions back. We're going to begin by using a method that's available on LLM instances called invoke. And check it out, like we can define our prompt here as a string. We can do llm.invoke and pass it our prompt. And right away, we've got a result back. And I think already, comparing it to using OpenAI in the previous, or the OpenAI library in the previous notebook, the amount of boilerplate this took is far, far less, and that's fantastic. We still have quite a bit more information than simply the response from the model. You can see there's this content property here that has an actual response. So oftentimes what we want to do is, instead of printing the result as we did here, we'll just get the content property, and that gives us just the text response from the model, right? Which here, when asked, who are you? It says, I'm an artificial intelligence model known as Llama. Llama stands for Large Language Model Meta AI. Okay. Now, we're not going to be looking at the rest of this response pretty much at any point in the course today, but I do want to take a moment to kind of like call out some of what's in here. In particular, these responses are going to keep track of the number of tokens that you sent to the model, and also the number of tokens that you received back from the model. Okay, now in discussing how large language models work at a high level in this course, I've used language like predicting the next word, right? Or sending a string of words to the model. But what actually happens is that our words, our human readable words, are actually converted into numerical representations called tokens. I think it's okay in terms of your own intuition to think about tokens as words. It's more natural just to talk about the model responding in words, but in actuality, it's responding in tokens, and it makes sense, right? Because what is a new line character, right? What is a question mark, right? Like, what is an emoticon? There's a lot of things that aren't actually a word, right? That can be converted into a token, right? So we need more than simply the string tokens that we send to a model. And furthermore, sometimes in English, we might have words that represent a single word, or we do have words that represent a single word, but there might be tokens for things like apostrophe T, right? Or special tokens for this is the beginning of the sequence of characters, right? Or a special token for this is the end of the sequence of characters, right? So all that to be said, again, we don't have to think about it too hard, but like under the hood, our sentences, which are typically human readable strings, are being converted to tokens. The model itself is generating tokens, and then those tokens are being converted back to human readable text when we see them in a response such as this one here. Now, if you're using third-party APIs, oftentimes the pricing model is such that the way you're being charged for using their large language models is on a per token basis, right? You get charged a certain amount for tokens you send the model, and you get charged a certain amount for the tokens that the model sends back, the number of tokens the model sends back. So with that in mind, it's important to know how to introspect and look at the number of tokens that you're both sending and receiving from a model. And especially as we're looking at prompt engineering, where oftentimes we're going to be constructing intentionally very large prompts, it might help to keep an eye on the number of tokens that's happening. So all that to be said, you can see that part of the response we get back says how many tokens were in the prompt, right? How many tokens were in the completion, and then just kind of summing those together, you can see the total number of tokens that this particular interaction resulted in. Again, if you're not working at like a systems level or a pricing level or an optimization level, it's unlikely that you're going to need to work with these terribly directly or often at all. But I wanted you to be aware of what they were. Okay, so having seen this kind of simple example, it's really quite straightforward. Now it's time for you to try it out yourself. So using our existing model instance, which we've already defined as LLM, create and generate a response of your choice. I'll pause the video here so you have a time to do it. And I really recommend typing it out. Of course, you can copy and paste, but this is a good time to actually kind of get into your muscle memory a little bit, how you generate prompts in a very simple way using LangChain. In particular, we're interested in the actual textual response of the model. So pause the video here if you like, work on this exercise, and then I'll gladly go through the solution together with you. Okay, hopefully you found that very, very easy to create and generate a response for a prompt. If we look at a solution, it's very much the same approach we took earlier. We're defining a prompt string. We don't even have to define this in a variable if we don't want, and then we're invoking, we're using the invoke method on our LLM instance and passing it the prompts. And then we're using the content property to get back our results. And here we have 3 puns having to do with LangChain. So, by completing this notebook, you should now have a very basic understanding of how to use LangChain to generate chat completion. Excuse me. Had a little bit of an interruption here. By completing this notebook, you should now have a really basic understanding of how to use LangChain to generate chat completions, and furthermore, how to parse out the actual model response using the content property. And we hope you agree it's really straightforward. In the next notebook, you're going to go a little further into using chat completions with LangChain by learning how to stream model responses and also how to handle multiple chat completion requests in batches. So we'll see you in the next notebook.